Hello, good day everyone. So, my name is Shalina and I'll be conducting Max Clinic for year 7. There will be two topics that will be highlighted for this clinic, and we are going to start with the first topic, which is chapter 3, taken from the textbook, shapes and geometric reasoning. Okay, so the subtopic that we are going to learn under shapes and geometric reasoning is transformations. Okay, so as you know, transformations, to transform something is to change it. In geometry, there are specific ways to describe how a figure is changed. The transformations you will learn about includes three main transformation that we are going to learn today, which are, the first one is translations, followed by rotation, and also reflection. Okay, so when you are going to do transformation, you will be having an object. Okay, so the original shape will be known as the object, and when you are going to transform it, okay, you will be going to form an image. Okay, so it is a common practice to name the shape, okay, using capital letters. It means that, okay, let's say you're given an object, okay, and the object will be having vertices, okay. The singular is known as vertex and the plural is known as vertices. Okay, so you're going to label the vertices using the capital letters. Okay, so as you can see here, you're given a square, and each of the vertices are being labeled as A, B, C, and D. So the next one, it is common practice to name transform shapes using the same letters with a as you can see here, you can see inverted comma symbol. Okay, uh, a prime, you can call it as a prime. Okay, for example, you can see an inverted comma over here. Okay, so you can call it as a prime, or you can even call it as a dash. Okay, so the I will be using prime here. A prime, okay, as you can see here, they are actually the corresponding vertex. Okay, A and A prime, they are the corresponding vertex. Okay, only that for the image, okay, we are going to use the inverted comma, which we are going to name it as prime. Okay, so the object is known as A and the image will be known as the A prime. So a translation slides an object a fixed distance in a given direction. The original object and its translation have the same shape and size, and they face in the same direction. Okay, so basically translations are slides, okay, which means that you are going to move the object into a fixed distance. Okay, there will be a specific instructions that will be given. Okay, and you have to move according to the instructions, but the object and the translated image, they will be having the same shape and size, and they face in the same direction. We are going to see some of the examples. Okay, let's examine some translations related to coordinate geometry. Okay, in this chapter, you're not going to learn about coordinates. Okay, but this is just how to say a review for you so that you can understand. Okay, how a translation works. Okay, the example shows how each vertex moves the same distance in the same direction. Okay, so as you can see here, the instruction given is slide 6 unit to the right. Okay, so this is an object. As you can see, it has been labeled as A, B, and C. Okay, so this is an object. So if you if the translation wants you to move 6 units to the right, each of the vertices will be moving 6 units to the right. Okay, so they must follow the same instruction, and once you have determined 6 units to the right, and you are going to label each of the vertices, okay, as a prime. Okay, you have to put the inverted comma, which you call it as prime. Okay, this is just an overview. We'll skip this slide. Okay, so as you can see here, there is another example on how translation works. Okay, in this example, the slide moves the figure 7 units to the left and 3 units down, or 3 units down and 7 units to the left. Okay, but the common practice is when you are going to do translation, you have to make sure that the object will be moving horizontally first, which is left, or to the right, and then only it will be moving vertically, which is up and down. That's how the instruction works. Okay, so as you can see here, this A, B, C, D, that is the object. Okay, this shape is the object which is labeled A, B, C, D, and the image is A prime, B prime, C prime, and D prime. Okay, and you can see the direction where it moves. Okay, just take one of the vertices. I'm going to choose A and look at the direction where it moves. Okay, so as I can see here, okay, just give me a moment. Okay, I can see that it's actually being moved 1, 2, 3, 4, 5, 6, 7. 7 units to the left. Okay, you can see the direction is moving 7 units to the left. And the next one, it's moving downwards. Okay, which is 3 units to the down. Okay, so as you can see here, this is the instructions for the translation. 7 units to the left and 3 units down. Okay, that's how you can determine the instruction for the translation. Okay, so and the other vertices also will be moving in the same instruction, same direction. Okay, and that's how translation works. Okay, so we will move to the next part of the transformation, which is a rotation. Okay, a rotation is a transformation that turns a figure about a fixed point called the center of rotation. An object and its rotation are the same shape and size, but the figures may be turned in different directions. Okay, so you have to know when it comes to when it comes to rotations, there are two main directions that you have to know, which is clockwise direction and also anti-clockwise direction. Okay, so the concept of rotations you can actually see in wallpaper designs, fabrics, and artwork. Okay, rotation basically are turns. Okay, just now translation was slight. Okay, rotations are turns. Okay, that's how it works. Okay, sometimes you can actually see this around you. Okay, let's say you see your wallpaper design, you will be having the same the same shape, same object with the same shape and size. Okay, the only thing is the position will be altered. Okay, it will be might be rotated, it might be changed. Okay, so that's how transformation can be actually related in your life. Okay, so this rotation is actually moving 90 degrees clockwise. Okay, so how do you determine it's moving 90 degrees clockwise? Okay, so first of all, you should know which way clockwise move. Okay, so clockwise is actually the movement of the clock. Okay, if you look at the hands of the clock, it will be that is actually clockwise. Okay, how it moves. Okay, that is clockwise, whereas counterclockwise or anti-clockwise, okay, is the opposite movement of the clock hands. Okay, so that's how you determine the movement of the clockwise and counterclockwise. Okay, so when you are going to do rotation, okay, the thing that you have to take note is the instructions given. Okay, so which if they ask you to rotate counterclockwise, sorry, if they ask you to rotate counterclockwise, you have to see. Okay, if counterclockwise is supposed to be moving in this way. Okay, it's supposed to be moving this way. Okay, and that means if 90 degree you have your protractor. Okay, and 90 degree is supposed to be something like this. Okay, so how is it going to rotate in 90 degree anti-clockwise or counterclockwise? And you get the from object you will be getting the image of rotation. Okay, the next part of transformation is a reflection. A reflection can be seen in water, in a mirror, in glass, or in a shiny surface. An object and its reflection have the same shape and size, but the figures face in opposite directions. In a mirror, for example, right and left are switched. Okay, so the very common occurrence that happens in your life is looking yourself on the mirror. Okay, that is the best explanation that you can give for your reflection. As you look yourself on the mirror, you can actually see the same size, I mean the same yourself. Okay, the exactly similar of yourself. Okay, same shape and size, only thing that you will be facing in the opposite direction. Okay, that's the best example for the reflections. Okay, so Rhine flip reflections are flips. Okay, that's how the Rhine reflections work. Okay, as you can see here, for example, mm, okay, as you can see here, okay, so this is the reflection, and there will be a Rhine reflection somewhere here, and that is the flip. Okay, same thing goes to here. It's a reflection of the bridge on the lake. Okay, and this is how it works. Okay, let me adjust. Okay, so this will be the line reflection. That's how the reflection works. Okay, they must have the line reflections, or also known as mirror line. Okay. Okay, the line where a mirror may be placed is called the line of reflection. The distance from a point to the line of reflection is the same as the distance from the point's image to the line of reflection. Okay, a reflection can be thought of as a flipping of an object over the line of reflection. Okay, so for example, as you can see here, okay, so let's say, okay, I'm going to choose one of the vertices. Okay, let's say I'm going to choose B. Okay, the distance from B to the line of reflection, okay, I'll use a straighter line. Okay, the distance from the vertex B to the line of reflection, let's say I'm going to put it as a 2 cm. Okay, so if the distance from the B to the line of reflection or the mirror line is 2 cm, you have to make sure that the distance from the line of reflection or the mirror line towards the B prime, okay, or the vertex point of B on the image, it must be the same distance. Okay, it must be 2 cm. That's how reflection works. Okay, so it applies on all the vertices. When you undergo reflection, when they undergo reflection, all the vertices will be undergoing the same, I mean they will be having the same distance. For example, if C, okay, point C to the line of reflection is 1.5 cm. Okay, the distance from the mirror line or line of reflection towards C prime is going to be the same distance as well, 1.5 cm. That's how you can determine if you are supposed to draw the image for reflection. That is how you can actually determine where the image is going to be by calculating the distance, okay, from the each point of the object towards the line of reflection or mirror line. Okay, another one more thing is, if you folded the two shapes together, the two shapes would overlap exactly. That's how reflection works. Okay. Okay, so we'll be having a review for the transformation that we just learned. Okay, so we are going to answer each of the question. Does this picture show a translation, rotation, or a dilation or reflection? Okay, dilation is another part of transformation which we are not going to cover this time because you're only required to know the three main transformation, which is translation, rotation, and also reflection. Okay, so you can see here, okay, you're given an sorry, okay, you're given an object which is ABC, which is labeled ABC, and the image is given here, which is A dash, B dash, and C dash. Okay, so what kind of transformation did this object undergo, okay, in order to form the image. Okay, so the answer is going to be, sorry, rotation. How do you know? Because the image is turned. Okay, so as you can see here, the image has been rotated, so it undergoes rotation. It doesn't get reflected. It doesn't move to into a specific direction. So it went through rotation. Okay, so the next one. Does this picture show a translation, rotation, dilation, or reflection? Okay, so what do you think? Okay, you are given the object which is A, B, and C, and also the image A dash, B dash, and C dash, or A prime, B prime, or C prime. Okay, so what kind of transformation it went through? Okay, so the answer is reflection. Okay, it undergoes reflection. Okay, and the line of reflection is at the x-axis. Okay, as you can see here, the distance from C, I'm going to choose one of the point which is C and measure the distance. Okay, so let's say, okay, sorry, okay, the distance from C to the line of reflection is 1 square or 1 unit, and from the line of reflection to C prime is also 1 unit. Okay, so this shows that it goes through reflection. That's how it works. How do you know? Because the image has been flipped over. Yes, okay, the image has been flipped over. So this is reflection. Okay, the next one. Okay, which of the following Latin figures are translation of the shape purple arrow? Name all that apply. Okay, so the next one we are going to figure out, okay, which one that undergoes translation. I mean, you're given an object here which is the purple arrow. Okay, so you have to find, okay, which shapes. Okay, you're given a few arrows here with letters on the bottom. Okay, and you have to figure out which arrow is actually the translation image of the purple arrow which is given earlier. Okay, so we can see 1, 2, 3, 4, 5, 6, 7 arrows. Okay, as you know, the rules for translation. Okay, so the object and the image, they have the same shape and size, only the position, okay, will be changed. Okay, so I can say that, okay, A is, sorry, A is the image. Okay, A is one of the image of the purple arrow. As you can see here, they have the same shape and size. Only thing that is different is the position. Okay, B is not, B is not the image of the purple arrow because it has been rotated. Okay, this doesn't go translation at all. Okay, and then the next one will be C is the image. Even the position is a bit different. Okay, but they still have the same shape and size. Okay, D is not an image of purple arrow. Okay, sorry, D is not the translation image of the purple arrow. Whereas E, yes, it is an image of the translation. F is no, it's actually a reflection. And the next one, G, obviously no, because the size is not the same. Okay, so the answer will be A, C, and E. Okay, letters A, C, and E are translations of the purple arrow. Okay, so they are asking, has each picture has been rotated in a clockwise or counterclockwise direction? Okay, as you can see here, this picture is being rotated in this manner. Okay, it's being rotated in this manner. So it's actually moving towards the, uh, it follows the counterclockwise. Okay, so Can you see it's actually following the movement of the clock? Okay, so this is a counterclockwise image. Okay, and this rotation, whereas you see this rotation, it's actually moving towards against the clock movement. So this is a counterclockwise. Okay, so you might be wondering how this works. Okay, so you look at the spiral which starts from the center and try to rotate from the center to the outside part, and that's how you can determine where is the direction of the movement of the direction, which is clockwise or counterclockwise. Okay, the next one. Okay, a tessellation is a way to tile a floor that goes on forever with the shape so that there's no overlapping and no gaps. Okay, in this case, okay, you can see the transformation is involved. Okay, um, okay, so there's one artist, okay, Dutch graphic artist MC Escher, is known for his creative use of tessellations in work. So what transformation can you see in this picture? Okay, this is like a trivia questions for you all. Okay, so you can see that you are given an image over here. Okay, and you have to identify what kind of transformation is involved. Okay, in this art. Okay, in this art. Okay, so you can actually see a fish and also bird. Okay, so what kind of transformation is involved here? So I would say translation. Okay, the transformation is translation. The birds and fish have been translated here. Okay, as you can see. Okay, the size, shape, and the directions of each of the bird and the fish are facing the same way. Okay, so they are the same, only thing is the position. So basically they are undergoing translations. Okay, you can see that this transformation can be actually applied in arts as well. Okay, so the next question. Okay, so there's a second art given to you. What transformations can you see in this astral print? Okay, I can see few birds over here. So what kind of transformation is involved here? Okay, so I would say mm, translation. Okay, you can see translation and also rotation. Some birds have been translated and some have been rotated. Okay, I'll give you example here. As you can see here. Okay, let's look at one of the birds here. Okay, I have one bird here and another bird here. They are actually the same size and shape. Okay, all of the birds is actually same size and shape. Only thing is the position. Okay, you can see these directions, these two birds, the direction, it's facing the same way. Okay, only thing is the position is different. So these two birds undergo translation. Whereas, okay, this bird, okay, let's choose the pink bird. Okay, this bird and this bird, you can see they have been actually rotated. Okay, so there are two types of transformation involved in this art, which is first one is translation and the second one is rotation. Okay, so we'll be moving to the next chapter, which is chapter 5, collecting and displaying data. Okay, so chapter 5, collecting and displaying data. Okay, so I'm going to show you a screen. Okay, you can see a lot of colors over here. Okay, so what's your favorite color based on this slide? Okay, so every one of us have our own favorite color. Let's say you're going to do a survey on what is the favorite color of the students in year 7. Okay, so you have collected the data. The thing is, how are you going to organize the data? Okay, so the first thing is organizing sets of data. Okay, so instead of you displaying your data like this, okay, a more organized way to show the data can be using the tally and frequency table. Okay, so we can actually put the information into a tally and frequency table. Let's say, okay, so we have favorite color here. Okay, so let's say three people likes the red. Okay, so you can actually count the people number of people who likes the red and do in tally instead, and then based on the tally we can actually calculate the frequency or the number of people who likes red. And it's you can do the same thing for the other colors as well. Okay, this is just an example. I'll show you how to do the tally table in a while. Okay, so as you can see here, the table has three columns. Okay, first is the data that you have collected. For example, in that survey you did the survey on favorite colors of the students. Okay, so the first column is going to be the data that you collected, favorite color, and then the second column is going to be the tally. Okay, and the third column is going to be the frequency. So this tally and frequency, they are interconnected. Okay, why do we do tally? It will be easier for you to calculate. Okay, it will be easier for you to do the counting. Sorry, to do the counting and to reduce mistakes. Okay, then you can convert the tally into frequency. Okay, and then the rows acts as the different data that you have collected. For example, students like red, blue, green, pink, yellow. Okay, all these you can actually display in a tally and frequency table. Okay, so let's see one of the survey that we have conducted. Okay, so let's see. This list shows the result of a survey to find out the types of pets owned by some children. Okay, let's say you do a survey and then the next thing is you're going to collect the data. It's like, as you can see here, the data that has been collected, you can see cat, cat, dog, 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 fish, fish, horse, bird, cat, dog. It looks very disorganized and it can actually make you confused. Okay, how am I going to read the data? Of course, you need to organize the data in a very, how to say, convincing display. Okay, so how are you going to identify? Let's say the question asks you, what is the most popular pet? How are you going to identify? So it's a bit hard to read the information based on the list given. Okay, so what are we going to do? We need to organize this information into a frequency table. Okay, so the equipment needed for drawing tables, pencil and ruler. Okay, so you are given a type of pet and then based on the list of the data that you have collected, you have to count. Okay, so how many of the students or how many of the kids, children like cats? Okay, have cats. Okay, so this is how you can actually display your survey done. Okay, so based on the tally and frequency table, you can actually answer few questions. Number one, what was the most popular pet? Number two, what was the least popular pet? And number three, how many people were asked? Okay, so you can actually total up the frequency to see the number of children that took part in the survey. Okay, we will see one of the. Okay, so far we only have just wait. Okay, so far the previous frequency table, you are only shown that individual data. Okay, like you are having a specific data which is cat, dog, fish, horse, bird and rabbit. Okay, you can actually show group values in the frequency table as well. Okay, for example, you are going to conduct survey on the heights of students in a year 7 class. Okay, so instead of you writing the height one by one, the height can range, for example, from 130 cm to 141 cm, for example. Okay, so instead of you showing 130 cm, okay, 130 cm, you don't need to write one individually. Okay, you don't need to write individual value. You can actually group them into one cluster. Okay, so which means that the first group will be having the data from 130 to 132, and then you have to count how many students falls in to this group value, and then followed by 133 to 135. And you have to make sure that the group that your group values, they must have the same range. Okay, so if there are three heights, okay, if 130, 131, 132, there are three heights in this group, the other groups also must be having three heights. Okay, that's how the group values work. Okay, let's look at first example. Okay, organizing sets of data. So the height of the students in inches from grade 4 is listed below. So you can see the list of students, height of the students given here, which is not organized. So how are you going to organize, organize the data into the tally and frequency table? So we are using the group value because as you can see here, the first thing that you have to determine is the what is the least value or least height of the student. Okay, you have to choose what is the least height. I can see here there's no 41. Okay, but I can see there is 43. Okay, I can see few 43 over here. Okay, let's say the first group we make it as 41 to 43. It will be easier for you. Okay, so and then you have to make sure that all the other group values will be having the same range. Okay, three measurements of height. It must be having the same three heights in the other groups as well. Okay, so let's see. Okay, how are we going to do the tally for this? Okay, let's look at the 41 to 43. So based on this list given, okay, just give me some time. Okay, so 41 to 43, we are going to check one by one. So which one falls under 41 to 43? Okay, I can see the first one. So what I'm going to do is I'm going to strike off the first data and I'm going to put the first line for the tally. So that's the first one, 43, and then followed by, okay, there's another one. Okay, so there are two data with that falls into this group 41 to 43, and then you can see here I have done two lines over here, 1 2. So my frequency is going to be 2. Okay, that's how I'm going to do my uh, organize my data. Okay, the next one 44 to 46. So let's check which one falls into this group. Okay, I can see 45. Okay, that's the first one, strike off, followed by 46. Second one, strike off, 46. Third one, strike off, and then 44 to 46. Okay, there's another one, 46. Okay, the fourth one, and the fifth one. Okay, remember when it comes to tally, instead of you doing a fifth line, okay, you are actually going to strike the four lines that you have drawn earlier, and this shows a group of five data. That will be easier for you to count the frequency later on. That is why you have this kind of tally. Okay, so okay, that's the fifth one, and this is the sixth one. Okay, and then you continue with the new group, and then 45 falls into this category. Okay, and then I can see 44 here, 1, and then 2. Okay, I have 4 here, and then another 45 here. So I'm going to strike another set of 5, and then I have 46. Okay, so I can't see any more 44 to 46 over here. Okay, I'm sorry, I left out the 145 over here. So the frequency is 12. Okay, as you can see here, this is the first 5, and then you add another 5, you get 10, and then you plus these two lines, you get 12. And then the next one, 47 to 49. Let's look at the 47 to 49. Okay, I have 1 here, 1, 2, 3, 4. Okay, this is my fifth one. I'm going to strike this, fifth one, and then 6, 7, 8, 9, and then 10. So I can't see any more 40. Okay, so the frequency is 10 as I have two sets of 5 here. And then the next one, 50 to 52. So it's going to be 1, 2, 3, 4, 5. Okay, strike it. 6, 7, 8, 9. Okay, so I have 9 over here. And the last one, 53 to 55. Okay, as you can see here, when you strike off the data, it'll be easier for you to look on the remaining data so that you can actually reduce your mistake, okay, when you are going to do a frequency table. So I have 53 over here, 1, 53 here, 1, and then 55 here, 1. Okay, and then, yeah, all the data has been strike off. Okay, so the frequency is going to be 3. So the next thing is you're going to total up the frequency to see that whether you get 36 or not. And make sure you don't put anything uh in this part, in this column. Okay, because you're not going to total up the tally marks, okay? You're just going to total up the frequency. So you have 2 plus 12, 14. 14 plus 10, 24, 24 plus 9, 33, 33 plus 3, 36. Okay, so that means you got your information correct. Okay, that's how you can actually reduce your mistake by doing this tally and frequency table. Okay, let's look. They have the sample answer over here. Okay, you do not need to put anything in this box. Okay, okay, so this was the tally that we did just now, and you can see that it's actually the same as what we did. Okay, so as the frequency was the same, and this is the correct way to do the tally and frequency table. Okay, the next method, okay, to one of the way to display your data once you have collected and organized is using a bar chart. Okay, using a bar chart to display your data. Okay, so you have to remember bar charts, they must have title, frequency on the y-axis, gaps between the bars, and bars with equal widths, label axis. Okay, so these are the 5 important things that you have to know when you are going to display the data. Okay, you must have the title for the bar chart. Okay, and then frequency. Okay, as you can see here just now, you are going to draw the bar chart based on the frequency table that you have drawn previously. Okay, so based on the frequency table, you are going to make sure the frequency is placed on the y-axis, and then when you are going to draw the bars, okay, the height of the bar is the one going to determine the frequency for each of the data. Okay, and you must make sure the gaps between the bars, they must be consistent, and the bars, they must have equal widths. Okay, you can't be drawing one bar with 1 cm width, another bar with 3 cm width. It doesn't work for bar chart that way. And you have to make sure the y-axis and x-axis, they must be labeled. Okay, these are the important things that you have to take note when you're going to draw a bar chart. Okay, let's say you're given a frequency table over here. Okay, so the type of tree, okay, oak, birch, evergreen, pine, and cedar, and the frequency. Okay, there are 2 oak trees, there are 5 birch trees, evergreen 8, pine 10, and cedar 7 trees. Okay, so how are you going to represent this on a bar chart? Okay, so you have 2 information, which is tree and frequency. As I told you just now, the frequency will be on the y-axis. Okay, so this is the x-axis. As you can see here, the horizontal line is the x-axis and the vertical line is the y-axis. Okay, and you have to make sure that you put scales on the y-axis, because that's the axis that's going to represent the frequency, and it's depending the numbers that you have in the frequency table. Okay, label the y-axis as frequency. Okay, so as you can see here, the first type of tree, which is oak, okay, the frequency is 2. Okay, so as you can see here, they leave 1 unit gap between the y-axis and the first bar that you're going to draw, And then the height of the bar shows the frequency for the oak. Okay, if it's 2, you have to draw the height up to 2. Okay, so and the width of the bar is 2 units. Okay, so that's what you're going to maintain for the other bars as well. Okay, the first one is oak, followed by birch, okay, which is 5. The height is showing up to 5. Followed by evergreen, which is 8. You can see here the line corresponds to the value 8 over here. And the next one, pine, okay, which is showing 10 trees. And cedar is 7. Okay, and you can see that the distance or the gap between the bars, they are consistent. They are 1 unit apart. Okay, they cannot be attached together, and they cannot be randomly having different gaps. Okay, they must be having the same gaps. Okay, so this is how a bar chart looks like. And they label the the x-axis as type of tree, y-axis the frequency, and x-axis the type of tree. And the title of the bar chart to show the numbers of types of tree in a park. Okay, and then bar line graph, how it works. Okay, so the difference between bar line graph and bar chart. Okay, so as you can see here, bar, it's using bars. Okay, they have a very thick they have a specific width, okay, which will be consisting of 2 to 3 units. That's a bar, okay. That's how a bar chart looks like. You need a bar. But bar line graph, instead of drawing the bar, you just draw a line, a thick line. And remember, the height represents the frequency. The characteristic of bar chart and bar line graph, they are almost the same. Only difference is the usage of the bar. Okay. So for bar chart, they uses bar, okay, the thicker bar. And for the bar line graph, it uses the thicker line instead of bar. Okay, but the frequency is still being showed by the height of the line. Okay, as you can see here, okay, all the type of trees are being represented using a thick line. Okay, and the gap is still consistent between the lines. It must be the same. Okay, so that's the difference. Okay, so additional information for you all. Okay, so we can actually compare two sets of data using bar charts, which is known as the comparative bar charts. Okay, place the bars for the two sets of data next to each other for each category. So you know, when you collect the data, you have categories, right? So you can actually uh, place the bar for two sets of data next to each other, okay, to show the difference between the data collected. Okay, let's say for example, eye color. Okay, you're going to do a survey on the eye color of the students. Okay, you have two types of students, which is boys and girls, two different genders. And then you have three eye colors, which is blue, green, and brown. Okay, so how are you going to display this in the bar chart? Okay, so it's the same thing. Okay, same rules. Y-axis is going to be the frequency. Okay, x-axis is going to be the eye color. Okay, so as you can see here, okay, you need two bars to compare the two different set of data, right? So which means that look at the first one. Okay, the eye color for the blue. Okay, so the boys is 9. So you're going to represent a bar until the height of 9. Okay, and for girls it's going to be 7. Okay, so as you can see here, there are two bars that are placed next to each other, okay, to show that they are actually in the same category, which is blue eye color, but there are two different data. Okay, one is for boy and another one for the girl. Okay, and they can be actually represented using different colors for you to easier to see. Okay, or you can even use legend. Okay, which means that instead of coloring them, you can actually do some patterns to show that, okay, maybe the diagonal lines showing the data for the boy, and horizontal lines showing the data for the girls, something like that. Okay, so the next category for green, four boys having green eyes and four girls having green eyes as well. They are placed next to each other. And the third category, which is brown, two boys having brown eye color and 4 girls having brown eye color. Okay, so this is how the bar charts work. Okay, and don't forget the title, bar chart to compare the eye color of boys and girls in year 9. As you can see here, this is the legend, okay, to show that which colors is showing the boys and which color is showing the girl. Or you can even use pattern as I mentioned earlier. Okay, so that's all for today's maths clinic. Okay, thank you so much. I hope this has been beneficial. Okay, and you have added some knowledge. Okay, for you have gained some knowledge. Okay, based on these slides shown. Okay, that's all for today. I'll see you again in the next round of maths clinic. Bye.